Hi guys, I'm Avery, one of the Averys, and my paper is on rest and stress resistance in aging and Alzheimer's disease. Or just rest, by me. So, rest, it helps you out a lot. When you take naps, it helps your memory, helps your blood pressure, you get rejuvenated, you feel better after naps. I just want to make sure you know this isn't the kind of rest that we're talking about. This is capital R-E-S-T. Rest is a protein. It suppresses a number of genes in your brain, which means it turns them on and off. So certain proteins aren't made. And the weird thing about this rest gene is that as you get older, it becomes more and more present in your brain. Here's just some graphs to show you this. Over on the right, we're looking at the receptor for the rest gene, RE1. The more blue there is, the more of the receptor there is in your brain. So as you get older, when you're getting into 70 to 90 year age group, you're looking at a lot more rest in your brain than in the 40s, and even 40 to 70. Over here, they took brain samples and stained the rest in green. You can see that the young age group is from 25 to 35, and the aged group is from 75 to 106. In the aged people, there's a whole lot more rest in your brain. So they went on to figure out why. What does rest do? We know it's a suppressor. We know it turns on and off genes in your brain. So what genes does it affect? These are the list of genes. Broken down, they're all part of apoptosis, Alzheimer's, and neurotransmissions. Important genes to worry about, right here. Apoptosis is cell death. These are all genes related to killing cells in your brain. And Alzheimer's genes produce proteins that are essentially related to cell death as well, and are known to cause Alzheimer's in older people. So what is Alzheimer's? Alzheimer's is a type of dementia, and dementia is cell death. Dementia is your brain killing itself, and so you can't function as well. It's linked to memory loss, declined thinking skills, impaired cognitive functions. You can't go through everyday tasks. You can't speak as well. You can't communicate or think things through. And Alzheimer's accounts for about 60 to 80% of dementia cases, and it's really only in older people, but symptoms can be seen in people as early as 40 and 50. Alzheimer's is a really bad disease. It's one of the top 6, or it's the 6th leading cause of death in America. 1 out of 3 senior citizens who die will die with Alzheimer's disease. There are over 5 million people living with Alzheimer's right now. So it's a pretty serious disease that we don't have a cause for, we don't have a treatment for, we don't have a cure for. We're not even close. So we want to know how rest was related. Hey, it works. This little graph over on the right here, or left, sorry. We saw this already, right? There's no green up here. In old people, there's a lot of green. That's what we're looking for. The red is just neurons to show it's in the brain. Then we get to Alzheimer's patients. AD and AD, these are 2 different types of Alzheimer's patients. They do take a test, the mini mind state exam, that's on a scale of 1 to 30. The first group is Alzheimer's patients who scored above an 18, so we're still relatively functional. AD2 over here is people who scored below an 8, so really can't communicate and can't do daily functions at all. So as you can see right here, there's no green. There's no rest in their brain.
Can you guys kill the lights? Gee.
And over here we're looking at dementia graphs. You can see the same kind of thing. Young people apparently don't seem to need rest at all, but in a healthy brain, old people have lots of green. Dementia, these are 2 different types of dementia. It's the same sort of thing, no green at all. Any questions so far? Yeah, Mr. Maxwell.
Are those are actually microscope-sized sections of brain?
Yes, these are.
They had to cut the brain to get them, right?
Yes.
Are these people dead already, or?
I don't believe so.
Okay. So they went in and cut healthy brain tissue out.
Yes.
Okay.
Any other questions?
Ouch.
No? Okay. So this is just a graph, a couple graphs to quantify the pictures we just saw. On the y-axis here is nuclear rest. That means rest in the nucleus of every cell. On the bottom here, you have young people, old healthy people, old mild cognitive impairment, and old Alzheimer's disease. Levels of rest are extremely depleted in Alzheimer's disease and in any sort of mild cognitive impairment. So anytime your brain isn't functioning properly, there seems to be a lack of rest here. Same thing goes with dementia. And this is just a different type of test to show the same thing. Anytime your brain isn't functioning, there seems to be a lack of rest. So let's look at why.
Question.
Question? Yeah. So,
Why?
okay.
If young people have even less rest than the Alzheimer's patients, then why do their brains still function correctly?
Because it's a breaking down over time that kills the brain. Young people don't produce the same proteins that don't produce the same proteins to break down the brain, so they don't need rest there to protect it. What rest does, rest turns off all of these genes. Rest binds to the DNA and stops them from producing proteins that will break down and kill the brain. What's up?
Do they know if, like, the people that have low amounts of rest and have Alzheimer's, do they know if they had the same high amount of rest that they should have, and then it went down as they got Alzheimer's, or do they always have the low amount of rest and that caused Alzheimer's?
Now, that's a good question. That's what they're looking to try to find. Is the lack of rest causing Alzheimer's, or is Alzheimer's causing the lack of rest? So what they believe is lack of rest is causing Alzheimer's. But that's a hard connection to really justify. Right here, these important proteins. This is a graph. On the bottom here are all the genes that are shut off by rest. And over here, rest chip is the binding of rest to these genes. So the more rest is binding to these genes, the better it is for your brain. The more your brain isn't dying, which is pretty important. Most important genes circled right here, BAX, DAX, and PSEN2. These two are really important in brain apoptosis, in brain death, and this is one of the main genes in Alzheimer's that produces a really important gene for Alzheimer's to function and kill your brain. What we're looking at, red is normal healthy brain. That is how much rest is binding to these genes in a healthy brain. Yellow, blue, gray are all dead brains, are all Alzheimer's diseased brains. Red is the AD, or yellow is the AD1 group that's still reasonably functional. Blue is the AD2 group who is very non-functionable, and gray is just a control. This is probably the best visual to see that when rest isn't working, your brain is not functioning. Which is why they think, back to Helena's question, that it's rest that's causing Alzheimer's. Yeah, what's up?
Can you go back to that graph?
Yeah.
So theoretically, because it's almost like an inverse, so the higher the bar.
Yeah. The higher the bar, the better it is for you.
Okay.
Because you want more binding to the brain, to
You
these
want them to be
genes.
suppressed.
Yes.
Okay.
So,
Do they know some either like artificially, I don't know, like artificially putting rest into the brain or something that has a similar function could actually work in Alzheimer's treatment?
we'll get to that. They just did, thank you for leading me right into my next slide here. They just did, so after that, they went to tests on mice. These are in vivo tests on little mice. What they did, they tested mice with rest they tested mice where they knocked out the rest allele, or sorry, not allele. Then they tested knockout rest where they added human rest back in, and they tested knocked out rest where they added rests that didn't stay in the nucleus back in because they thought it was important. They wanted to see if it was an important function of the rest to stay in the nucleus of each cell. So on the bottom here, these are different brain stresses. H2O2, hydrogen peroxide, is just a stress to kill off the brain. A beta 42 is an Alzheimer's protein that can be naturally produced and break down the brain into Alzheimer's. On the side here is cell viability and how well the cell survives and when it's exposed to these stresses. The white blocks are normal rest. The black blocks are knocked out rest. The striped blocks are knocked out rest with real rest put back in. The really important part of this graph right here is the striped blocks right here. When rest was knocked out, the mouse brain died, which goes back to saying without the rest, lack of rest causes brain death, as opposed to dead brain having no rest. But then when they added the human rest back in, the mouse brain survived better than with the normal wild type rest. So this is really hopeful for a possible future treatment. It needs to be explored a lot further, but this is one really good sign. Over on the right here, we just have a couple more tests to show that you only need rest as you get older. I think Diana asked the question of how come you don't have it in your brain when you're young and how come your brain doesn't die. You just don't need it yet, the proteins aren't being produced. So on the bottom here, most important part of these three graphs is the neuron density. That's how dense your brain is, how many neurons are actually in your brain. So at 1 month old, little baby mice with rest and mice with knocked out rest are exactly the same. They have the exact same brain density. After 8 months, mice with rest have more or less the same brain density as before. Mice without rest have gone down about 25%. They lost about 25% of their brain because they don't have this one protein, which is a really serious decline in brain density. Any questions before I go? What's up?
So these are normal mice that these are just being done in, or is this the Alzheimer's disease
Normal
mouse? And I should probably know this, but do you know how, what does 8 months in a mouse correspond to in a human?
8 months in a mouse corresponds to 50 years, I think. About 50 years, yeah. Anybody else? Light's just shining on my face. Okay, so the main thing to take from this is that rest is neuroprotective. That means rest saves your brain. It keeps your brain from dying. Expression during aging keeps your brain healthy. Without rest, your brain dies and kills itself. It represses destructive genes, and most importantly, a couple graphs I didn't show here, it stops stress damage. Like the H2O2 damage that we were looking at, it stops oxidative stress damage from you stressing out or just other stresses that are put on your brain. And it stops damage specifically by the Alzheimer's protein, which is really important. It keeps you functioning and it keeps you able to be, down here at these graphs, it gives you better cognitive function, better perceptual speed, better memory in every situation. This is just showing z-scores for memory tests, perceptual speed tests, and just overall global cognitive function versus how much rest you have in your brain. As you can see, there's a trend going upwards in every single one of these graphs. Yes?
When does rest start developing, like, in your brain?
You can go back to the first slide for one more. Right here. Right about 70 years of age,
Okay.
in this group right there is where it starts coming up. Anybody else? Okay. One more. There we go. Okay. So in every single area, rest is related to better function, which goes back to the theory that rest stops Alzheimer's instead of Alzheimer's creating less rest. So what this could mean. Right now, it doesn't mean too much. This was just a test on what rest does. But there's no known cure for Alzheimer's. There's no treatment to stop or slow the progression of Alzheimer's. Right now, the only thing that, if you have Alzheimer's, you can take is temporary drugs to alleviate the symptoms for a week or a day. There's really nothing we can do. So this offers hope. This is something that is now directly related to Alzheimer's, directly related to the Alzheimer's protein, and directly related to your brain killing itself, making it possibly a really important puzzle piece in curing this disease. And thank you. That's my presentation. Any questions? Andrew?
You mentioned that that they were looking to see if rest was necessary for rest to be in the nucleus.
Yes.
For it to work. What were the results of that?
Yeah. If rest is delocalized outside of the nucleus, it doesn't function. We can go back to this. Here they added rest outside of the nucleus, and it was just as unfunctional as knocked out rest. There are a couple other graphs I can give you if you want them specifically later. That just show once it's delocalized, they have little nice pictures like these that show when the rest is outside of the nucleus, it's not all condensed like this. It's not functional really, and doesn't help the brain at all. Ellen? That's just a gene expression issue. DNA mutations that don't express the right genes, or don't express the right proteins, lead to less rest, leading to diseases. Anybody else? Is that it? Okay, thank you.
Who's next week?
Jackson Hoyt.
Oh no. All right, next week Jackson Hoyt will be doing something boring about reptiles. Where is he?
Can you bring your snakes in?
Oh, I can't make fun of him when he's gone. No, I'm kidding. Jackson's always a good presenter. And I don't remember his paper. Mark, do you?
It's about a species of lizard that only have mothers and not.
Oh, right. The all-female species.
It is reptiles.
Yeah, it's definitely reptiles. I hope to see you guys all next week. Thank you for coming. Thank you, Avery.